Hello and welcome. In this video, you will learn what scientific notation looks like, how to convert from scientific notation to standard notation, and how to convert back from standard to scientific. First, we're going to understand why scientific notation is important. Scientific notation is used to show a condensed version of either really large numbers or really small numbers. Throughout this video, you will want to take some notes. You will have the option to pause, rewind, or fast forward. After the video is done, you'll need to write down one question you have about scientific notation. We will go over those questions tomorrow in class. You will also need to write down 2 specific things that you learned from this video. Let's get started. This is an example of what scientific notation looks like. Notice that the green number has to be equal to or greater than 1, but still less than 10. And the purple number has 10 with an exponent. The 10 will always need to be there, and the exponent always has to be an integer. An integer, remember, is a positive or negative number. Let's go ahead and get started with actually trying a scientific notation question. This question says write 3.22 times 10 to the 4th in standard form. What we're going to need to do first is rewrite this decimal right here, 3.22. Next, we're going to figure out how many times we should move our decimal in this problem. The exponent, 10 to the 4th power, actually tells us right away how many times we should move our decimal. Since our exponent is 4, we're going to move our decimal 4 times to the right. 1, 2, 3, 4. I'm going to fill up any empty spaces with zeros and then rewrite my answer without the decimal swoops. Here's my final answer, 32,200. Here's another example where we have 6 times 10 to the 7th, and they're asking it to write it in standard form. Again, we're going to start by writing the decimal, but notice that the number 6 doesn't have a decimal written with it. It is common knowledge that 6 is also equal to the decimal 6.0, so we can go ahead and write that instead. Notice that our exponent is 7. So that means we'll be moving our decimal 7 times to the right. Here we go. Once we're done moving our decimal 7 times to the right, we'll fill up the empty spaces with zeros and then rewrite without any decimal swoops. For our grand total of 60 million. Notice how big 60 million is and how small we were able to write it with scientific notation, just like we mentioned before. Part 2 is going from standard notation and writing it back into scientific notation. Let's say we're given an example like this. First thing we're going to do is rewrite the number. The next thing we need to do is remember the requirements for scientific notation. The first number will need to be between the numbers 1, greater than or equal to it, but still less than 10. Where I need to put my decimal will be between the 1 and the 6, because that will make the decimal point be 1.65. Also in scientific notation, we have something being multiplied by 10 and then an exponent that goes with it. Remember, the exponent tells us how many times we should move our decimal. So in this case, we're going to count how many times we should start from here, 1.6, to get to the very end of our number here. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since we move it 9 times to the right, my exponent will be 9. So the final answer will be 1.65 times 10 to the 9th. Here's another example. 268,000 is in standard notation, and we want to write it back in scientific notation. Again, you want to start off by rewriting the number, figuring out where your decimal goes. In this case, it'll go between the 2 and the 6 because it makes the decimal 2.68, still meeting the requirements for scientific notation. We know that we need to multiply by 10, and then the only thing we need to do now is count our decimal movements. 1, 2, 3, 4, 5. Since we moved it 5 times, my exponent will be 5, giving me my answer of 2.68 times 10 to the 5th power. This concludes the video on scientific notation. Remember, you will need to include one question you still have about scientific notation and write down 2 specific ideas that you learned while viewing this video. Thanks for tuning in.